probably a good day just to pay attention and understand the concepts rather than try and hurry up and follow with the components. As some of you are finding out, it takes a long time to learn how to do stuff, and it's not done by rushing around and copying me. So last session we talked about using the BHoM, and there's a few key things that you had: adapters and you had objects. Objects are things that you create, objects that represent what you want to do. In this case, we had said the main object that we wanted was the panel object, because the panel object in the BHoM was the thing that represented best our problem, which was a panel of glass, which has not only this outline, but it has this internal spider connection, which is an opening, a property. We didn't give it a name, but we could have given it a name. And basically, there was the object creation, which we'll get into in a bit. There was the adapter creation, which basically we said if you create an adapter, effectively what you've learned to do is open up a piece of software from Grasshopper, let's say. You can also do it from Dynamo. So right now it's trying to open up Robot. We had chosen Robot because we said Robot does good finite element analysis, and that's what we need to do to analyze this thing. I don't know why it's doing that. And then we said the main operations that you can do, you can send information to something like a robot adapter, right? So Robot's now open, there's nothing inside of him. Meanwhile, over here in Rhino, you have some information that's starting to geometrical information, which we can put here very easily. Equally over here, on Grasshopper side of things, we have information related to materials, thicknesses, yada, yada, yada. So after class last week, me and I think we left off with the ability for us to take, again, we're in green mode here. If I click this, that's the outline of the panel. The panel's outline is an arc, curve, ellipse, NURBS curve, blah, 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 right? The opening, again, is an arc, curve, ellipse. Everybody reads that. You know what it wants. What does the computer see? Don't give him a number, don't give him a this, don't give him a that. Give him any of those things and he'll accept it. And the property, which is a property that we had defined, right? So the property is actually something that is something called constant thickness. Constant thickness, what does it have? It has a thickness, which is a number, a material, which is another BHoM object. So again, we go up the chain and we say until we actually can feed stuff in, we're not done. In this case, it says steel here, but I'm going to change to glass because there's no real difference materiality-wise between this glass and the steel. Steel has modulus elasticity, so does glass. It has Poisson's ratio, all that other jazz. And I think last week where we arrived was if I take this panel and I push it into the push, we go over to Robot, I think a few of us had this last week where we were getting like this weird situation where you couldn't actually get the window to look right. I've used Robot for years, I've never seen this. So in general, word to the wise, get used to this, is when you are accessing these computer programs via the back door, you have to get used to going to the task manager, completely killing them, checking your task manager for are they in the background running somewhere, and then we restart it. So again, I go here, we turn it on. Now the problem that we ran into last week was we were able to get over, what we should witness here is we were able to get over the panel itself. So just something that in the BHoM is called a panel, and actually consequently in Robot it's called the panel. Okay, it's not actually that the BHoM took the name from Robot. Robot calls it a panel coincidentally. Everything in the BHoM is called what it is because of completely separate reasons. There is no link between necessarily the BHoM and other software, right? It's completely agnostic. So in other words, ETABS, if you would use ETABS, which you wouldn't for this, but ETABS, a finite element solver, he would call these things, these panels, they would call it shells. And another software calls it this, that, and the other, right? So the key is that we're completely, when we're building our objects, again, it's pushing to Robot right now, but until it's in Robot, it has no connection at all to any piece of software. It's completely being described outside of the realm of robot. So all of this stuff right here, just as easily as you could take it right now, it's a panel. Again, we talked about last week. We build stuff up left to right, and we take stuff apart right to left, or left to right as well, right? So I can explode this and undo what I did before. This guy's saying he doesn't like me. Why not? I believe we had this working last week, at least the first one. Okay, so this guy's not happy. We did something here. I have a feeling I know why. The call is ambiguous between the following methods. Ooh, that's scary talk. Polycurve and polyline. So I think it's very strange. I think I get this one to work. You'll see this a lot, guys. This will be, if you want to be able to do something better than you could before, you'll have to just deal with turning red. It happens. I use this every day, and it still happens to me every day because it's not meant to be perfect. It never will be perfect. I'm just going to redraw the inputs because I know I had it working. I'm working off of someone else's information here now, so I'll just redraw a couple of curves here. Say that my spider's rectangular as well. Set one curve. Again, I left the adapter on right now, so the adapter actually himself is trying to work for me, so I'm going to turn him off. Because these curves here that I'm feeding in, they're hooked up to a lot of other things. I zoom in, here's my opening. I'm going to add an opening. All right, so now my panel, right, if I click him, he looks like that, right? And let's try him again. Okay, he says success now. So what did I do? I changed the input, and it apparently worked now. And boom, there it is. Right, actually, it looks like it worked both times, just looking at this. So you see we pushed it over a couple times. One is Bianchi's without an opening, it looks like, and one is mine with an opening. And actually, the bonus is, on this one, we have supports right away, which we didn't get to last week. And how is it that we got the supports? Because last week, we just said, let's send over the panel on its own, right? So we sent over the panel, and that was no big deal. So I'm just going to delete what's over in robot, just to make a point here. So if I send over this guy, he's thinking. You can see robots kind of flickering around over here. All we get is that, right? Now I'm going to delete him because I said we need to get on there. We would like some supports around the spider, let's say. First thing we did, though, was we kind of looked and we said, you know what? How do we actually apply to the edges some sort of support? And what we did was we actually said, take the panel apart. Let's see what's inside of this panel. Let's see if what actually makes up a panel. So panel is made up of external edges, right? And that was the first thing we noticed. And then we learned, oh wait, an edge has a support and a release, which makes perfect sense if you know anything about finite element analysis, right? So we said, actually, is there another way for us to make this panel in a way that doesn't just take in an outline and an opening as a curve? Remember, this guy takes in only two curves and a number right now. What this told us was we want to actually be able to create it from something called an external edge, an elements.edge, because the edge itself has a support on it, right? So what we did was we did our Shift Control B, we said panel, and lo and behold, if we looked under panel.structural, what did we find? That there was a bunch of different ways to create a panel, and some of them actually took in, as you see right here, a list of edges rather than a curve. Okay, so that's very important because that's telling you, again, remember chapter 1, what does the computer see? This guy right here, if I go back, one of those is this guy, one of those is this guy. To you, they both look almost the same. They take in 4 inputs, outline and external edges. You might just look at it and go, it's just, that means the same thing, right? And they both say panel, they must do the same thing. But actually, they do not. Because if I try and give this guy, who is a curve, over to this guy, who is an edge, what does he do? Cannot convert from BHoM geometry polyline to BHoM structural elements edge. Okay? Extremely important concept that, again, this stuff's been thought out. It's really useful. You'll be able to make all the finite element models that you want using this. But without the knowledge of basic object-oriented programming, the chapter 1 stuff that we talked about before, you're not going to get very far because they do useful things for those who know what they mean. So in this situation, instead of throwing in a curve, we said, I got to go find something called an edge. What do? Shift Control B. I say edge, right? And I know that the edge is in structural right here, and that it takes in a curve, hopefully, but also some sort of releases and some supports. How do I know that? Again, we did some investigation of what an edge actually is, and we found that it has a curve, a release, and a support. Is everybody with me so far? This is all literally prerequisite to being able to get the useful stuff out the back end here. So this guy takes in a curve, he takes in a support, and again, the support, where do I get it? Shift Control B, support, right? There's a thing called a support. In this situation, I think we found it was pin support is what it's called. Maybe edge support. Can't find it. How do we find it if we can't find it here? Create object, right? And we go to select method, structures, right? We know this is an element, or actually this is probably a constraint, right? And then constraint 6 degrees of freedom, right? Pin constraint 6 degrees of freedom. That's how I found it. Okay. So you got to get used to being able to either Google search it with Shift Control B, or looking for it in the menu. And this guy's name is pinned, and therefore if I push him over now, he'll come over and he has a support. So it takes a second to push him over, but that's one of the key things now is we've pushed over more information. And again, most of that information is non-geometrical. Most of that information is information related to finite element, okay? Now, the problem is we had said, well, I want a spider support that goes around the middle here, right? We don't want it just around the outside. So that was one of the biggest problems that we had. So we did say that actually, if we look at again, we know that edges have supports. So if we look at openings, openings have edges, and edges therefore should have supports, right? And we see the exact same thing. So in the exact same manner as we said before, why don't we go and look for a way of creating an opening that takes in edges as opposed to here where it just takes in a line? Okay, so we're going to do the exact same thing we just did here, except for these edges, we don't really want them to be supported necessarily for what BHoM was talking about. The new software, purportedly, if you punch in a hole, he'll give you a beautiful support right there without you having to go around. I know what your guys' pain is because I use this software as well. You'll mesh this thing. You'll mesh it to a reasonable tolerance. And then you'll spend your time, that was pretty quick, and now you're going to spend the rest of your time going in here and kind of trying to quickly select these guys and then going over there and pinning them up, right? And it takes 3 seconds each time, therefore 30 seconds for each spider, and there goes your day, right? So we don't want to have to do all that manual clicking. We want the support to show up on the edge just as easily as it showed up on the edge of this panel. Wouldn't that be great? We wouldn't need to buy a new piece of software. We can run this model right now. You know, I've done this trillions of times. Modeling in robot, you can come up with brilliant stress plots. So how do we do that, right? So we say, let's apply that thickness, that support to the edge of an opening. So we say, let's go create an opening, right? Let's do it from this menu right now. Create objects, we're in structures, right? And then you go elements, let's find opening. Opening's right there, opening. Ah, shoot. Everybody see that? We don't have an option here for us to be able to create an opening based on edges, okay? If we go to panel, we have that option to create it based on edges. You can see that right here. And you can also create it based on openings which have edges. But where's our access point for being able to create an opening based on edges? It does not exist in the BHoM yet. Very key lesson. The BHoM is for free. It's out there. It's constantly developing. And should you care enough to open up the code, you could fix this. That's not the topic of today's lesson. You have to know C#, you have to know a bit of GitHub, but it's available to everybody in the world, what we're showing today, right? So it's very worth thinking about, starting to think, I need to learn that in the next year or so, because it won't be long before other people start to say, well, if it's that free and that easy, I'm going to use it myself. Big time warning. So we tried to do a little bit of a faff here, me and Byongi. We said, listen, what we can do is we can create an opening, right, based on, again, it says edges here. It's incorrect to say edges, right? Because it should say the edges in this situation aren't edges, they're curves, right? So if we throw them in, we get out what? If I hover over this thing, BHoM structure elements opening. But this elements edges, which have been created, if I explode that edges, it should have no supports, right? Because the supports themselves have not been applied. So it says null there, right? So we said, how about this? Let's create the thing the only way we can do it, take it apart, reassemble it based on how we want it, right? So we explode it, we take its edges, right? And we say we're going to set their property. We know one of his properties. What's a property? A property is anything on the right side here. That's a property of an object, okay? So in this case, the support property is nothing in it, right? So if we say, please set the support property to the value of this pinned degree of freedom, and then we explode it. So let's put these side by side. Our first go has nothing in it. But now, at this point in the script, after we modify it, the support has something in it. And if I explode the support, what is the support? The support is another object which has a bunch of stuff in it, right? Again, any engineer worth his salt kind of would expect that that's what a support object contains, right? So we're just massaging the information into back now. So we've said the opening has edges. The edges now will have supports. Therefore, the original opening, we're going to set his edges to this new edge, which has supports. And there is my new opening. And this guy, instead of asking for a curve, he's asking for a list of openings. Now he turned red. Why? Because I didn't have time to fix this before you guys came in. BHoM elements opening, right? So what did you ask for, Mr. Guy? List of opening, BHoM. So what's going on here? Especially if I create this guy and I put him in over here. Oh, he didn't like him either. There is no love lost on that guy. Let's see here. If I put him in here. So that just proves it, right? He didn't like something I was doing with the geometry. So this guy, he's a polycurve. Before we had a circle and it didn't like the circle. So I put in this sort of polycurve now. And I was faceting the circle before. Now we don't really need to do that. So we have one opening. We have another opening down here, which has been added in a support. So if I take this guy and I put him in here, he doesn't turn red. Yes. So in review, what should we have? A panel which has external edges. We don't care about those too much. We care about the opening, which has edges. And what should the edges have? Should have a pinned support. Boom. Everybody see that? This is taking an object apart. This is putting an object together. And if I kind of exaggerate this screen a bit here, What does it normally look like? We talked about this last week, right? That everything kind of on this side of things converges down to one thing, right? And on this side, everything sort of opens back up, right? So you have to think in terms of, at this point in the script, not only do I have the geometry that I see in Rhino, of course I see that picture in Rhino, but I have a ton of other information if I go searching for it. Now for the moment of truth. Did we actually get what we wanted? So if I delete this guy, I think this is where we left off last week, Byung-Gi. We couldn't get the final step here. Does he turn red? My money's on it turns red. It turns red more than it turns gray.
That's fine.
Oh, don't jinx it. Hey, how you doing? All right, there we go. Everybody see that? Now we have the support there, right? And we officially don't need to buy new software because of free things that are available on the internet. So whatever that software's name was, they're in trouble from the perspective of anybody who gets a hold of this. They don't need that software anymore. That was quick, okay?
And okay, so then
questions, yeah.
Then I was wondering whether, because sometimes we may need to have only one side support or two side support, not entire edges.
Yep. Okay, so let's do that now. So the entire edge, in fact, in this situation, I think.
Then second question is, okay, what the data and how we can get the pull the data back to Rhino.
Okay, let's do one at a time there. I think those are both valid, but really important questions. All right, so the first question, that's nice, but I don't want to carpet bomb, this thing with a bunch of edges. Let's say we only want to select this guy as the edge to support, right? Okay, so somewhere, somehow, some way, we have to, it always comes down to, we have to tell the computer, which edge gets supported, right?
But what about if you create another layer in Rhino saying support?
Yes. So we've done this before, right? On some of the stuff with these guys for the BD submission stuff. There is no magic to say, if you and me right now, we sit here as engineers and we say this edge, I'm gonna just draw it like this. This edge right here is the guy who is supported. There's a multitude of ways to say that guy's supported, but this other guy is not. It could be based on just you. Maybe it's just you who knows that. Maybe it's based on the fact that we have another, like a beam running through here, kind of like this, like a primary beam, a primary mullion or something. There's a lot of different ways, and this is chapter 3, which is chapter 3 and chapter 2, association. If you had a mullion here, let's do it like that. I think that would be a good thing to show, is if we, because usually that would be the best thing, is if we had a system. Okay, so here's what we're showing, guys. This guy right here is a mullion. Fair to say? We might have a mullion modeled as many different ways, but for sure it has a center line that we care about, right? So I'm going to change his color by changing his layer, or just change his layer. So what I would think would be very useful for you guys, so again, I'm going to very quickly clean all this up, okay? So let's get this thing to, this was all just experimental.
Okay.
So what's doing the work here? Before we move on to the next one, I'm just gonna say that's our first hack. So we draw a line here. I'm gonna lock my screen, and we're gonna copy down what's doing all the work. So what's doing the work? That's creating the opening. That's our opening. That's our external edge, right? That's the edge. We need that stuff. We need this stuff. Let's just clean it up. Nice and clean. And we want these guys. Okay, turn these guys off. Again, I did that middle mouse wheel, so nothing's doing any calculations and slowing us down. Okay, so let's bring these guys up here. What's this guy? This guy is the external profile. This guy's the opening profiles, right? What else do we got? This guy can go This guy can go. And for now, we should put in more data buckets like this here, but we're got limited time, so let's move on to the next stage. So if I turn this back on, should try and push it again actually. So while that's going, let's take a quick sketch here and say what our plan is on paper. So our plan on paper is that what we're going to put into this system is, we had that mullion running through here, right? And then we're going to say we also have this custom pen. I'm going to draw it very like this. My pen is not happy today. Boom. We're going to give him, at least for the outer profile, he gets those, right? And for the inner profile, again, he'll get something like this. Make sense? So the real question is how do we tell him if this is, let's say A, B, C, and D, our eyes can right away say which edge should be having a support and which edge shouldn't be. Which edge should have a support analytically? A, B, C, or D? One link. Which edge should have a support? D, right? Makes it. Now here's the thing. Now that's clear to everybody in this room, but the computer has no idea what's going on there, right? So now the question is how are we going to make that association between bar 1 here, which is the mullion, we're calling it mullion right now, data-wise it's a line, and D, which is the edge of a panel, which currently, before it's actually a panel, it's a line or a part of a polyline, right? So we know that we have to make an association between these two guys, because what we really want to do is we want to say there's A, B, C, and D, right? And what we want to do is we want to say A, B, C, and D actually all together, they go as the edge of the panel, right? In the long run. But actually in the short run, these guys will go straight over and become an edge with no support. But this guy will become an edge, and in addition to that, we'll have a support. Does that make sense? So this is null.
Yeah, let's try to support the D and the whole.
Let's just do it manually first, okay?
Okay.
So if we did it manually, first thing that we do is probably we go back to our beginning here. Probably need to explode him, right? So middle mouse wheel, explode. He's going to make my, and I made a rookie error here. What was my rookie error? I left my robot adapter on. So now every time I click, I'm waiting around for 5 seconds, 10 seconds, in this case 30 seconds, for stuff that doesn't mean anything to go to robot, okay? So be careful. I just put up a post yesterday on Yammer that says, hey, listen, just because you're working computationally doesn't mean that you're working intelligently.
So we better save robot file separately?
I'm not saying save robot file. It's if you keep this on, this toggle, then every time you make a change that changes this, which in this case is, it'll keep trying to run it, right? So in general, a good habit is to use something called a button. And the button only works when you click it. You click it once, it goes once. Okay? Just let me see something real quick. Okay, we got some battery left. I might have to get my battery. Right. So, external profile now went crazy. Why? Because we destroyed the thing that he was linked to. Now it's 4 curves out here, right? So worst case scenario, again, we say external profile, let's say 1, or not supported, let's say, an external profile supported, right? So I got the supported one selected. I say set one curve. I have the rest of these guys now. Set multiple curves, right? This guy's getting a support. If you guys see this guy, so he's hooked up to the right guy. This guy will get no support and will need to be hooked up to this guy. And therefore, if I flatten those especially is a good move here. Better component, not to give you guys bad habits, but to merge them into one list, just like we showed on the other page. So we've made 2 types of edges based on 4 different curves. And now I'm ready, as long as nothing's over here, to see if we can do that. I double clicked it like a dummy, so something might happen. You single click it. Uh-oh, new problems. Okay, so if we look there, the new problem is very apparent. We got one edge supported, but we also happened to screw up the order, right? So obviously the order is what is mattering here. I think, give me 1 second. There's a trick here, as I recall. The trick is there got to be sort of in an order that kind of makes sense. There's a couple different ways of handling this. In this situation, what I'd be tempted to do, and it's a typical move, so you guys can learn from this. A very typical way of doing this is to find this point right here, find this point, the midpoint of each line. Convert these, you guys are all going to start going, what are you talking about? Convert these to polar coordinates. So, you know, polar coordinates where basically each one of these has an R and a theta, right? And then sort the theta and then do it. Okay, so we have an ordering problem right now. This is chapter 2, because you can't make this thing work. You might be sitting here and going, man, we almost got it, but I can't get this to work because the order isn't correct. And now I'm going to have to actually go in there when I do this and actually be very careful, because what you could do is you could say, because right now there's no way of sorting these things, right? Unless you actually said, copy these, right? And one at a time go, and this might be helpful to you if you only have to do 1 or 2 of them, right? 1, 2, 3. This is painful already, right? So let's just see what it does, right? Now we're forcing the order on the machine here. 1, 2, 3. Oops. My computer's really slow right now. I think it's not so happy with me. It's so laggy. Okay, now hopefully we've forced the issue that we want to see here, so we won't see this jazz. And we see. 1 click. He's thinking. Did we get it? I'd say we did. Was it as automated as could be possible? Absolutely not. But if you were sitting here right now and only had to do 1 of these and didn't want to have to click all the way around every time, then you've just saved yourself probably a few minutes each time you have to do 1 of these, right? Equally, the supports, I assume, it's always going to be the supports would have been the one that take you the internal supports that are the longest one, right? And those ones right now are pretty easy to do, right? Because you just send those over and they all get supported, right? So if we made, let's see if we can do 2 supports. Is everybody still happy? Everybody's still happy. So let's see. So those rectangles are spider connections. We could make them into circles. We just need to look into why it wasn't liking the circle that we happened to draw. And even if you didn't have this as a knife edge support, there are other ways to make this happen. Whoops, looks like the similar problem, right? So somewhere in here, let's see what happened. That looks like it tried to take everything we gave it and make it into one opening, not two openings. So what's happened here? There's one opening there that's come out. So actually what we need to do, the magic, is that. Now there's two openings. What's that called when I do that? What did I just do to make the problem go away? Yeah, what's the opposite of graft? And what do you do when you're just starting off in Grasshopper a lot? Just try and graft and try and flatten it and see if it made your problem better. That's got to be backhand. But still didn't work in this situation. Looks kind of cool.
So also we have to select individual things.
Yeah, it's very interesting. I don't know. It's obviously not a problem for one, right? So it's not an issue of the input, because if it works for one, it should work for two. I'm wondering if maybe we just try and push over the openings, right? So what if we just say, let's delete the openings right now and see if we can just push over openings as their own thing. Maybe something's going wrong when we try and push over the openings in the panel at the same time. Obviously cannot do that, right? Oh wait, it's not done thinking, so it is done thinking. So what's the problem here? Again, we're at the same, we're actually getting better, because last week we were sitting here and having the same problems with the panel, right? Now we've got the panel supported. We know how to support it on one side versus another. And the question is Mr. Panel, why can't you take multiple openings like you say you will, right? So we forced it to have multiple openings. What could we do here? I'm going to try a little trick that sometimes works magically. Let's try this one. Now the good news is we always have problems with any piece of software, anything that we use. There's always things that it doesn't do for us and doesn't work so well. See this one again. I think this one's probably one for next week because I'm about to run out of battery. But this guy right here, yeah, we'll cover this next week. I'll have to look into this. The good news on this is because it's open source and because if you're a bit driven, you can actually go to the code and figure out what is he doing. These are just steps that the computer goes through. So when I push over in the robot toolkit, so we'd have to look up the robot code, but there is a very specific part of the code that says when you create a panel and create the openings of the panel, I do this, this, and this. That can help us solve this problem. That, as long as you are willing to go into this thing and determine what's happened, we can solve the problem. It's not hidden to us. As opposed to what we're used to, so if I say create, and I say panel, there's one in, there should be one in here for opening. Don't really see it right now, jumping off the page, but panel, right, it says for each opening, right? So it's doing something here for us. The problem is almost certainly happening there. We just have to inspect this a bit. But I think we'll save that for next time. But the key is, to end the day, is that you have to go in there now. I can give you this script, but the key skills that, we can give you a script that does something like this. But for you to get something that's really, really useful is going to have, because it's going to turn red. It's going to turn red the second I walk away from you. And if you don't understand the ideas of objects, of adapters, of hovering over this thing and saying, what do you actually want? Oh, you want a curve? You won't be able to get very far. So this tool is extremely powerful, but it requires a lot of the stuff that we've been talking about for the past year in terms of chapter 1, chapter 2, chapter 3. What does a computer see? Filtration and association.